Hi guys, and welcome to this Houdini tutorial. Today we're going to take a little bit of a look at copy stamping within Houdini. Again, one of the core pieces of Houdini that allows you to do very unique things with multiple iterations of instances, which is really cool. So to kind of get started, I just have a fresh Houdini scene, and I'm going to generate some geometry to actually work with. So I'm going to hit tab and type geo for geometry. I'm going to press I to go inside this geometry node and delete out the file node since we don't particularly need it. Next we're actually going to create a sphere node and set it to polygons. To bring up that menu again for generating nodes, you have to hit tab and start to actually type. And the cool thing about it is it does keep a spare history, so that if you actually want to generate things that you're using quite often, it's all there. So once we have a polygon sphere, we're actually going to increase its frequency a little bit. And we actually need some geometry to copy onto this particular sphere. But maybe we'll introduce some nice kind of movement to the sphere to kind of show some kind of working method. So let's drop down a mountain again, hitting tab and typing in mountain, and wire it up and hit on the display flag, which is the far right one, or you can hit the eye. And we're going to set some animation of this particular mountain node. So you can set the height and the overall scale and the element size to whatever you particularly like, and even the noise itself is up to you. I'm going to leave mine on simplex, which is okay. And for the offset, we're going to use attributes, so at time with a capital T, which again is the time in the current time in seconds. And if we press play, it will actually animate for us. Again, this is kind of running at too fast, so we have to turn on real-time toggle, and it will run at correct speed. Next, we're actually going to drop in an object to copy to every single point that is on this particular surface. And what we can do is maybe drop in a platonic solid. And a platonic actually allows you to select between multiple objects of what you want to generate. It will be by default set to a tetrahedron, but you can put in dodecahedrons or isosahedrons or all types of stuff. Soccer balls and the very common Utah teapot. So I'm going to put in a dodecahedron. It's fun to say. And I'm going to drop in a copy stamp node. So instead of a copy to point, which just does exactly what it says on the tin, copy stamping actually gives us access to some very clever parts of Houdini. So again, if you hover over the two inputs for the copy, it will actually tell you what it's looking for on each one. And the first one is primitives to copy, which is going to be our platonic. We can wire it up. And our mountain node will go into the points to copy to. And if we visualize our copy, you can actually see what's happening. Now our platonic is relatively big to begin with, so I'm going to decrease its radius, or leave it at 0.5, and maybe we just increase the radius of our sphere in general to begin with. And what I'm doing here is middle mouse button clicking on the parameter, or you can do this on any particular input here, and it gives you the interactive numeric ladder. And this allows you to increase either all three values at the same time based on this, or individual values by a factor of 10. So you can increase it by 0.1, you can increase it by 1s, you can increase it by 10s. So it allows you to rapidly change the outlook of your effect really quickly. So we can kind of scale out And I'm just going to move the camera further back so I can kind of see what's happening. Again, this display is a bit cumbersome because of the copy node, so I'm just going to drop down a null that will allow me to view that without any kind of blue lines in the way. There we go. So you can see what's happening. We actually have lost a lot of kind of height in our mountain because we've scaled up, so maybe I'll increase my mountain scale. And if I press play by pressing up on the keyboard, it will animate through. So, I mean, this particular effect is quite cool in itself. However, we can make it much, much cooler with our copy node, or copy stamping. Now, copy stamping allows us to create variables that will allow, based on any particular geometry, we can kind of create variables to start to affect the incoming mesh. So we're going to go to our stamp node in the middle and say stamp inputs, and this accesses all of these variables. We can create up to 50, and I'm just going to call the first one scale. Now it's set to a value of 0 at the minute, but I actually want to randomize that based on the amount on every single point coming into this object. Now, on that kind of point, if we visualize our mountain, the important thing to note is that every single thing in Houdini actually has a piece of data assigned to it. So every single point has a point number, and every single primitive, or every single face, I mean, also has a number. And you can actually start looking at this data by going to the Geometry Spreadsheet tab. And again, remember, you can add this particular tab anywhere you like by going to New Pane tab type and say Geometry Spreadsheet here. So on this, we actually have a toggle between points, vertices, primitives, which are faces, and detail, which is the object as a whole. And this here is actually listing every single point on that particular node. And we have an attribute here called P, which is position, and we've got X, Y, and Z coordinates. So point 0 is actually at these specific point in space. So that is important to note, because we can actually access that particular data to generate quite cool things. So on our copy node, we're actually going to go to our value for scale and type our first expression. Now it's a bit small here, so I'm going to expand it for you guys to see properly. So I'm going to go to edit expression, and we're going to type in the expression rand, R-A-N-D. And what random actually does, if you start to type it and open up the brackets, it'll actually tell you what it does and give you some examples. So it gives us a pseudo-random number between the values of 0 and 1 based on what is inside this particular bracket. So as you can see, if you wanted a random value based on every single frame, it would or that changes every single frame, you could type in this $F or at frame, or at time also works as well. What we're going to type in here is at ptnum. Now the attribute of ptnum stands for the point number of the mountain node. So what we're doing is, for every single point number of the mountain node, we're giving a random value between 0 and 1. And if we hit apply and accept, that will generate a random value for every single point number coming into this copy node. Next, we need to access this particular value, and that comes into our copies themselves. So after our platonic, I'm going to drop in a transform node, and we can visualize that if we want to. And what we're going to do is affect the uniform scale based on that randomly generated number for every single point. So we need another expression. Again, I'm going to go to my edit expression so you can see it's a little bit better. And we're going to use the stamp expression. And again, you can kind of see what it does. It gives us information about using it. It's looking for 3 sets of data, 2 strings and a float. Basically, it's looking, the first one is looking for the node that generated the particular value that we want to access. The second is the variable that we created. And then the third is, if it cannot find that value, what should I return anyway? Again, you can actually see these values here. So first of all, we're looking for the copy1 node. That is where we set up that particular value. And the way that you actually access that is through a directory structure, and the shortcode for getting to another node is to jump outside of the current node that we're in. So we're currently inside transform 1. We have to jump outside of it to actually access any of these nodes at this level. So the code for that is ... And as soon as I do that, you'll see that we do have access to everything else here. And I want to access copy1 and close double quotes to close the string. Then it's comma, and we're looking for the variable that we created, and if you remember, we called it scale. So I'm going to open quotes again and type in scale. And then the third argument is, if it cannot find that scale value, what should it use if it can't find it? And generally you kind of keep that to 0 and close brackets. Hit apply and accept, and when we visualize the copy1 now, you'll actually see that, or sorry, the null one, every single copy now has that random value being assigned to it. We can actually go back into our copy1 and start to adjust our random value here. At the minute, this is assigning a random value between 0 and 1. But if we wanted it between 0 and 3, we could multiply that that expression by 3. Maybe that's a bit much, maybe by 2. We're actually getting quite nice results. And if you didn't want to scale all the way down to 0, you could perhaps plus 0.5 at the very end. So now we're going to have a random value for every single point number that goes from 0.5 to 2.5. And your order of math is multiplication and division before addition and subtraction. So that is the way that you kind of read that. So again, this is all entirely animated, and this is only the first value that we've actually started to manipulate. Any of these particular parameters, and indeed any node that comes before the copy on this structure of the object that you want to affect, can be manipulated by the variables that you actually create here. So for instance, with rotation of this particular object, we could affect that too. So let's do rot for rotate, and this one will want to create a random number for every single point, so pt_num, and instead of it being a random value between 0 and 1, I actually want it to be a random value between 0 and 360 degrees. So we can multiply that by that. And in the transform, I can choose which axis to maybe rotate around. So I can maybe rotate around the x-axis. And if I type that in, so it's going to be stamp, then quotations and ... to jump outside of the transform1 node. I want to look for the node that created the variable, which is copy1. And then the second argument will be looking for that rot variable, so quotations, ROT for rot, close the quotations, and if it cannot find that value, what should it return? Just return 0, please. And then close up the brackets and hit enter. And although it might be a little tricky to tell with these particular values, you can actually see that all of those particular spheres have been rotated randomly based on all of their copies. So again, you can get really in depth with all of this. Even the platonic itself, we could change its radius, we could change its entire solid type based on the random values that we assign within these variables in the copy stamp node. So it's incredibly powerful, and it is only the beginning of utilizing the copy stamp node. So definitely play around with it. It's great fun to kind of see what you can generate. Okay guys, stay tuned for more Houdini content.